Now let's continue to determine the limits of f of x, and we have another piecewise function over here. F of x is x squared as long as x is smaller than 0. So in this part of the graph, we're going to have y equals x squared. And y equals x squared in this portion of the graph will look like this. I won't draw a table of values because I'm confident that all you guys are very comfortable with quadratic functions, and graphing quadratic functions and equations, essentially. And if not, I suggest that you just check out our website and refresh your memory. So, and one observation, of course, is that here we have x is smaller than 0. We're not including 0, so we actually have an open dot here. That point is not included, as far as we know right now, unless we had this. X is smaller or equal to 0, then this point here would be closed. We would include it in our function. Then, for values that are greater or equal to 0, we have x plus 1. What does x plus 1 look like? Well, we have a y-intercept of 1 and a slope of 1. So it will look something like this. But of course, we just want this function in this portion of the graph because that's x is greater to 0. So it will look like this. Okay, and we have a closed dot here. Why? Because x is greater or equal to 0. So we're including this point on the graph. And okay, so now we can determine the limits. Limit as x approaches 0 from the right of f of x is, well, we're approaching from the right, so we're coming from this direction. And as we approach, or as x approaches 0, we hit y equals 1. So if x equals 0 coming from the right, y equals 1. So that's equal to 1. But what if we're looking at the limit of f of x as x comes from the left? That's what this little minus here means. We're coming from the left. So as x approaches 0, and of course this is 0 for x, right? As we're coming from the left, it approaches 0. Even though that value doesn't exist, we're still approaching the 0, right? It's going almost there. It doesn't quite hit that point, but it converges towards it. So the limit of f of x as x approaches 0 from the left is just 0. And finally, we want to determine the limit of f of x as x approaches 0. For this to exist, we have an important condition. We need the limit coming from the right and from the left at that value, which is 0, to be the same. But in this case, they're not the same. It's 1 coming from the right, 0 coming from the left. So essentially, this does not exist. The limit of f of x as x approaches 0 doesn't exist. But of course, the limits coming from the right and the left do exist. That's it.